8, 10. Yeah. So how do we solve problems where the equation is given? It really should say, how do we solve problems where the equation is given and is nasty? Just completely nasty and not a whole lot of fun. And the reason it is nasty and not a whole lot of fun is because it's a basic level math problem where they're giving you everything but one variable. So when you start to look at these and go, that looks so tough, ask yourself, if I gave you, y plus x equals 7 and said solve for y when x is 2, well, you'd be like, well, that's pretty easy. I can solve for y when x is 2 because I can subtract 2 and get y equals 5. Now, that's a very simplified version of what we're about to do, but it's the same idea. They're going to give us every single number in here but one. Okay, either they're going to give us the number for m, p, and r and make us find n, or more than likely p, r, and n, and they're going to make us find something. So we are probably going to have to work backwards and do a little bit of work, but it's algebra, but algebra with some nastier decimals, but the idea is the same. You have one variable, get it alone so that you can solve, which is not a lot of fun. So let's read the first question. All right. Monthly mortgage payments can be found using the formula below, and it looks like fun. There it is. M is the monthly payment, P is the amount, R is the rate, N is the number of payments. So we have the Banks family. Kind of funny that they're called the Banks family, but whatever. The Banks family would like to borrow $120,000 to purchase a home. They are qualified for an interest rate of 4.8%. So we have our rate. Start off with that, right? 0.048. We got that by dividing 4.8 by 100. Then we have our P, which is the amount we would like to borrow, $120,000, amount borrowed. So this is P, okay? 120,000. And there we're going to keep on reading. Of course, I can't erase the y equals 5, but whatever. So the bank family decides they can afford a payment of $720. Well, the monthly payment, I guess I'll put that in a different color so it stands out, is $720. So that is your M. Okay, so this guy right here is $720. So they want to know how many years the nearest tenth will they be paying on their house. How many months is that? So on and so forth. And here's where the fun begins. So we're going to plug in now. We know what M is. They told us M was 720. So step 1, plug in. Step 2, cry a little bit. Step 3, continue working. The principal amount is 120,000. The rate is 0.048. And then we have to do 1 plus that to the power n. Come on. And it's all over, again, 1 plus the rate over 12 to the power n minus 1. So there are a few things that you want to do right off the bat. Anything that you can do, it's very basic, simple math, even if it's in the calculator, which a lot of this, most all of this will be. You need to do that. So first thing I'm going to do is I'm going to take care of what all this is, what all this is, and what all that is. Okay, I'm going to figure out what all those decimals are. So I have 720, come on. Okay, it's going to equal, now when I multiply 120 into all of this right here, I get 480. And then the decimal that I get when I figure out what 1 plus 0.048 over 12, which happens to be the exact same decimal for here, thank goodness, is 1.004. So I guess I can put parentheses around this. Again, both of these say 1.004, okay, to the power n. Alright, so this problem becomes nasty. Well, I have two n's in it. I'd only like to have one n because I'm trying to solve for n. So I'm going to solve this by cross multiplying. So I'm going to put this bad boy over 1. I'm going to cross multiply. And this is the weird part. When we cross multiply, what we get. I'm going to expand this a little bit so I have some room here. Alright, so I get 720. Has to be multiplied by both parts. 720 is going to get multiplied by this guy right here and this guy. So I'm going to write that 720 parentheses 1.004 to the n minus 1. Okay. And it's going to equal the right side, which doesn't change, 480, 1.004 to the power n. So, again, like I said before, I have to multiply 720 by both things. Okay, I can't multiply 720 times the 1.004, and this is something a lot of people miss. They're not paying attention to it, but this has got an exponent, so I just write it next to it. So this becomes 720 times the 1.004 to the power n. That's a multiplication symbol. And then minus, well, 720 times 1, right? 720. Now, let me see if I can erase this real quick. I can. So if you notice on both sides, right here and right here, I have 720 groups of this nastiness, and here I have 480 groups of this same nastiness. So what I'd like to do is subtract them and bring them all to the same side. Okay? So if I had 4 groups of something, and on the other side I had 3 groups of something, I could subtract the 3 x's over. This is the same idea, except I'm doing it with some really, really ugly things right here. So I'm going to subtract. I need to undo that. Okay, so I need to subtract off the 480, 1.004 to the power n. So I'm going to subtract off the 480, 1.004 to the power n. And at the same time I do that, I'm going to add the 720 over, because I know that's supposed to be on this side over here, so plus 720. So now I get 720 is on the right, and when I do my 720 minus my 480, it's like 720 x's minus 480 x's, right? I'm going to end up with 240 of those same things. So I get 240 of the 1.004 to the power n's. Well, now it's a problem that we've seen before. We just need to solve. So we're going to divide by 240 on both sides. I now have 1.004 to the power n equals. I'm dropping the parentheses. There's no real need to have them anymore. It's going to equal 3. This is now a log question where I change it from exponential to logarithmic form. So again, log base 1.004. Base will stay the base. Okay, and then switch the other two. Or remember that a log always equals the exponent. Go to your calculator, type it in. This gives you n. N becomes 275.2. Well, hopefully that's not years, but let's pay attention, go back up to the question and see what it's talking about. N is the number of monthly payments, so this is months. Okay? Whereas the question also says how many years, right? How many months? How many years? So it's 275.2 months. We're going to divide that by 12. So divide that, come on. So 275.2 divided by 12 is going to give us a number of years, which works out to be 22.9 years. Okay, we're going to jump into the same style problem that we just did, except now we're going to ask ourselves the question of the Banks family decided they can afford an extra $100 each month. That's the key here. So what happens when you pay just an extra $100 per month? So let's go through and label everything. The amount to borrow that we have in here again. This is going to be your P, amount borrowed. Probably would help to have a better colored pen. So there's P, 120,000. Your 4.8% is going to be your interest rate. Okay, so this is going to be your R, annual interest rate. You have to divide by 100, of course. And the monthly payment, M, is now going to be 820. So we're going to plug in again, just like we did before. Plug into this formula so we can see and solve, I should say, for how long. Okay. N. All right, so 820 is the start. That's M. Equals P, which is still the $120,000 home. Just increasing how much we're going to pay. The rate is still the 0.048 all over the 12. That's 0.048, and it's 1 plus the 0.048. Again, that's 4.8 over 100. All right, all raised to the power n. And all of that is going to be over 1 again plus the 0.048, the rate divided by 100 to the n minus 1. So using your calculator real quick, it's not rocket science, you type those in, come up with an answer. So first you're going to do the, come on, 120 times all that fun, get 480 when you do that. And 1 plus 0.048 over 12 is still 1.004, same as it was on the last page, so that didn't change. Again, it's going to be all over the same thing, 1.004 to the n, and then minus 1. And it's still 820 equals that. The idea is still the same, put that over 1 and cross multiply. So when we do that, we end up with 820 multiplied by both parts. And then 480 times the 1.004 to the n. It's still the same because it's multiplied by 1. So now we have to distribute this 820 times both parts. So we get 820 times the 1.004 to the power n. And then 820 times negative 1 is just minus 820. The right side does not change. We are not allowed to multiply that 480 in. Because of that exponent n. So now we want to combine like terms, move things around. So if we subtract the 820 over, we have 820 of these 1.004 to the power n's, and we're going to subtract it off. It doesn't really matter where you put the n. I just noticed that I have them different on each side. 1.004 to the n, parentheses, or parentheses n, doesn't matter in this case. Both of these are saying the exact same thing, 1.004 raised to the power n. So I have 480 of those things minus 820 of those things, and they're the exact same things, so we're allowed to subtract. It's like terms. It's just weird because we have a base and an exponent. So when we subtract 480 minus the 820, we are going to get 340. So come on, change here. So we get negative 340 of all of those 1.004 to the n's. And on this side we get negative 820. Dividing both sides by the negative 340, since we can't multiply it in, we have to divide it over. We end up with a fraction because I don't really want to write the decimal. I'm lazy just like you, and I don't want to take the time to write it all out. But when you type that in the calculator, the TI Inspire calculator that is, you end up with 41 over 17. Equals the 1.004 to the n, and now I need to change it. This is going to be changing it using Venn. So off to the side if you need to see it. Sorry for those of you who don't. B to the e equals n. We have it in that form. We're going to change it to the log. Base stays the base, and the log always equals the exponent. So we have the base of 1.004, so it's log base 1.004. Alright, those are supposed to be zeros. I'm sorry that they didn't. So 1.004 of 4 over 17. And the log will always equal 41. Log will always equal the exponent, so equals n. Sorry, this is not writing very well. It's throwing me off a little bit. So type that in the calculator. So log, that says base of 1.004 of 41, that's supposed to be over 17. Type that in the calculator, you get an answer. That answer is 220.5. So that's months. All right, and then take that answer if you want to figure out the number of years, divide it by 12. So 220.5 divided by 12 is going to give us 18.3, which we will round to the nearest year as 18 years. So when you take a look at that, you have 18 years here. When you're paying extra $100 a month, it's 18 years. Okay, and then the first time was 22.9. So just by paying an extra $100 a month, you've taken off almost 5 full years. Okay, 18 versus about 23. Almost 5 full years is rather interesting. That's a lot for just $100 extra per month. Okay, next example. Another tons of fun question. Okay, assuming a liquid starts at a temperature of 200 and begins to cool in a room at a state temperature of 70 degrees Fahrenheit. After 5 minutes, the temperature of the liquid is 153. The equation that can be used, again, is given, and it's nasty, and they all involve T. Look at it, there's 4 of them that have a T in it, for crying out loud. That's just disgusting, and that's what you're going to see. They're going to give you a formula. It's going to be nasty. You have to read carefully. You may need to read it 10 times. You may need to read it more, and that's okay, as long as you figure out where things actually go. So let's start to go through it. Alright, so assume that a liquid starts at a temperature of 200. So temperature, that must be the initial temperature, is 200. Okay? This guy right here, initial temperature is 200. That's our T sub 0. It says cool in a room that is the temperature of 70. So that's the temperature of the surrounding liquid, right? The temperature surrounding the liquid, so this is 70. That's the temperature of the room. After 5 minutes, so the time is 5, the liquid temperature after T minutes is 153. That is tons of fun. Not really. Okay, so it even says, use the given information to solve for the decay constant. So they're telling you in the first part of it, hey, you're going to solve for K. It's not a lot of fun, I'm sorry. It just isn't. There's no way around it. It is just a miserable question. So we're going to plug in our variables. Okay, the value of T, the temperature after a certain number of minutes, after the 5 minutes, is 153. So we start off with the 153 equals the temperature T of A, which is the temperature surrounding the liquid, we said was 70, plus T sub 0, which is the initial temperature of 200, minus T sub A, the temperature surrounding the liquid, e to the negative K times T, which we said is 5. Nobody really writes negative K5, so we'll switch that to negative 5K after we do some work. So, first things first, I'm going to subtract the 70 over and get 83. And I'm also going to do the 200 minus the 70 to get 130. And then I'm going to change it to negative 5K. Now this is a problem that you've solved before. Looks pretty familiar to you, or at least it should. We have to get it so that it's pretty much the base of the exponents alone, and then we're going to use changing it from Venn form, exponential form, to logarithmic. So we divide by 130. So we have 83 over 130 equals e to the negative 5k. And now we're going to change it to the log form. Log base e of the 83 over 130 is going to equal our negative 5k. Remember, the log always equals the exponent, the base stays the base, because a log is just an exponent. Anyways, type that in the calculator, divide by negative 5, and you end up with k. Now it says to go to the thousands, so that's 3 places after the decimal, so 0.090. And again, the part that I did skip is dividing both sides by negative 5, but you can type it in the calculator and divide by negative 5 and you're good to go. So that's the value of k. Here's the key word here. And there's a key word. It says then, using your constant. So using this value that you now have, determine how long it would take for the liquid to reach a temperature of 100 degrees Fahrenheit to the nearest minute. This is a nasty question because too many people, far too many people, don't understand what the heck it's talking about. It's saying using k. Now, here's the problem. I will see a ton of people take all of these values that you have up here, plug them in, and k. The problem is if you plug them all in, including the time is 5, you can't possibly find an answer because there isn't a missing variable. You do need to think about that. So, let's plug back in with what we know. and keep going. So, plugging in, we want the temperature to reach 100. All right, reaching 100 is the temperature after t minutes, which is the t, the first part of the problem. So our new t value is now going to be 100. It was 153 before, but that was just so we could figure out what k was. So 100 equals the temperature surrounding the liquid. It doesn't appear to have changed. It's still 70. So we're still going to have the 200 minus 70. That didn't change. But what did change is that we're looking for t, and they've now given us k. Now it's supposed to be raised to the negative k, which is 0.090 times t. And again, this is a problem that you've solved before. It's a problem that we just solved before, part A. So we're going to subtract 70. We're going to subtract 200 minus the 70 to get the 130, and keep going. So subtract 70 to come up with 30. The 200 minus 170 here is 130. E to the negative 0.090 t. Dividing both sides by 130, we get this. Oops, 0.090 t. We're now going to change to logarithmic form. Finally said it right. Log base e of 30 over 130 equals the negative 0.090 t. Okay, go to your calculator, type it in. When you're done this side, you're going to divide both sides by negative 0.090, and you'll have your answer. T works out to be 16.29, so that is t equals 16 minutes. So when the calculator says determine to the nearest minute, you're just rounding it, okay? And you're good to go. All right, example 2b is just like example 2. Just another problem for you to see it. So the 40 degree roast, that's the initial temperature, so that is your T sub 0, okay? So that is our T sub 0 is cooked. That's supposed to be a 0. Wow, that's a bad 0, I'm sorry. It's cooked in a 350 degree oven, because that kind of makes sense. So that oven is the temperature around it. So what is that one? That is T sub A, temperature surrounding the roast. All right, the oven temperature is the temperature around it. After 2 hours, so that must be your time, T, lowercase t. It looks like a plus sign, I'm sorry. The temperature of the roast is 125. And this right here is the temperature of the roast after T hours, so it is capital T. Okay, so it looks like they gave us everything but K in this first part. So I'm guessing that's what they're going to have us solve for. And it says in part A, using the information given, solve for the decay constant. There you go. Okay. So we're looking for that constant. In this case, it's the growth constant. So we're going to plug in and work backwards to solve. All right. So we have T, which is the 125, we said, capital T. T subscript A, we said, was 350. So we'll plug that in next. Next, we're looking for T sub 0. So it's plus T sub 0, which we said was 40, minus the T sub A again, which we said was the 350, all multiplied by E, the negative K times T, which is negative K times 2. So from there, we're just going to solve, all right? It's 2 steps. I'm going to do it once. I am going to subtract over this 350, and I'm going to combine what's inside parentheses here. I can't multiply it by the E because, well, it's got an exponent, but I'm going to do that much. So subtract 350, we can do that. End up with negative 225. I'm going to combine 40 minus the 350 and come up with negative 310. And again, that's still times E. And I'm going to write negative 2K. We don't ever see X2, so you don't really going to see K2, all right? So negative 2K. From there, I have to divide by the negative 310. I am trying to get the base to the exponent alone when I'm doing this right now. That will get this part alone so that I can change it to log form. So again, that fraction is not nice, just like it wasn't on the previous couple pages. So I'm going to leave it as, when I get my pen out, 45 over 62. equals our e to the negative 2k. And now I have the variable as the exponent. I can't solve for it the way that it is, so I'm going to change this to log form and run out of room at the same time, apparently. So this is going to be log, base stays the base. All right, the log will always equal whatever the exponent is, so it's going to equal negative 2k, which means that the 45 over 62 has to end up inside here. Now, you can go to your calculator, type this in as log base e if you want. If you hit the pi button, that'll give you the base e. Or since it's log, you can just do the natural, log base e, you can just do the natural log of 45 over 62 equals negative 2k. Either way, you're going to end up with the decimal, and then you have to divide that answer by negative 2. So I'm going to skip all over that. I guess you can type it in the calculator. It's not a killer. And to the nearest 10,000ths, you end up with 0.1602. So again, what you need to understand in those questions is that you just did all that work to find the decay or the growth constant, depending on the problem. So when we're finding that, they're now going to ask you to use that and do the exact same thing again, which is kind of obnoxious. But now you're going to be solving for how long it will take, more than likely. Let's see. So if the roast is done when the temperature reaches 165, okay, to the nearest tenth of an hour, find t right there. How long will it take the roast to cook? So nearest tenth, find t. So that means we have to use this value of k that we just got up there, which was the 0.1602 that you can't read because I scrolled up too far, or down too far. So we now need to plug in again, but this time we don't know t and we do know k. Okay, so they're changing one other part too, right here. That's the roast is done when the temperature reaches 165. So the temperature of the roast after t hours is now going to become, our capital T will now become 165. Okay, so this is capital T. That is not what I wanted to write it with. All right, so I have 165 is now our capital T. It's still going to be the same T subscript A, which is 350, plus it's still 40 minus the 350. But this time it's e to the negative 0.1602, because that's k, times lowercase t, which is what we're looking for. So it's the same style question as before. You need to recognize that. They're just giving you different numbers and saying, okay, now that you have the constant, right, using the problem that we gave, the known values that we had, now that we have that constant, let's do a little bit of work and solve for t. Well, it's still the same, it's the same style question, it's just got slightly different numbers between the 125 and 365, and now we have a different k value. So it's the same problem essentially, again. That's obnoxious. You can count on the Regents to do things like that. So subtract over the 350, and do that. I had this time come up with negative 185. 40 minus 350 is still negative 310. We still can't multiply it by the exponent, or by the base there, because of the exponent. So I'm going to divide both sides by negative 310. Again, dividing both sides by negative 310 will give me a nice fraction. The decimal was not much fun to write. 37 over 62 is faster, so I'm going to take that option. Solving it, we're going to have to change this to logarithmic form using Ben again. I'm not going to copy it this time. You saw it last time. Base stays the base. Essentially, you switch the other two, or you can just remember the log always equals the exponent. So which one of these bad boys is an exponent? We got all this, this, or this. That's got to be the exponent. That's what it should equal, because a log is an exponent. And then 37 over 62 goes here. Type that in your calculator. Again, you can use natural log or log base e, and then you'll divide both sides by the negative 0.1602. Just keep that all in your calculator. That way you don't mess it up, or round when you shouldn't round. And you end up with t equals 3.2 hours. And that's that. Next page you'll find, I believe, is the summary. And don't forget to do your practice. Thank you.